Okay, so in this investigation, we are going to be graphing the sine graph, but with various values of a, which are going to either compress or stretch the function vertically, or even reflect it, as we'll see. So let's take a look. I have here on the grid itself just the base function for sine. Okay, that's sine without any kind of transformations. So I guess I'll label this just over here with y equals sine x. Okay, I'm just foregoing the function notation f of x. And I'm going to basically graph sine with different a values, and those are indicated here along the side. So I'll start off with an a value of 1/2, and I'm going to change my color to green to indicate that curve. There we go. And the function I'm going to look at will be f of x equals 1/2 times sine x. And I'm doing this over the range of negative 360 to 360. You know what, let me maybe bring this over here. So what am I essentially doing? Well, if you look at this, I mean, you can always generate a table of values, but I'm going to skip that. I'm essentially multiplying every value of sine x by 1/2, or in other words, I'm dividing it by 2. So for example, when x is 90 degrees, the y value, or sine of 90, is going to be 1, but half of that will be 0.5. And when x is equal to 180, my y value will be sine of 180, which is 0, and half of 0 is just 0, so that'll just end up staying where it is. Half of negative 1 will be negative 1/2 over here. Half of 360 will be, well, sorry, half of sine of 360 will just be half of 0, which is 0 again. And 0 at the beginning, well, that will also be half. So what do I have? Well, if you connect these dots with a smooth curve, as such, you have a sine curve which has been, I can think of it as being compressed, okay, vertically by a factor of 1/2. Or sorry, stretched, sorry, not compressed, stretched, compressed, confusing myself here. Compressed, okay, vertically by a factor of 1/2. And just to be complete, I'm going to copy this. The same image basically goes in the negative, for the negative values of x over here. And you can see, the superimposition of the two curves, shows that compression by 1/2. So you see this kind of push downwards, or this push upwards over here. Okay, well, let's move on. I'm going to now look at a stretch value, and I'm going to have to change this up a bit because unfortunately the 3 is not going to fit in here. So I'm just going to put this to a 2. Okay, so I'm looking at this guy here. The function is going to be f of x equals 2 times sine of x. Now, just like I multiplied each y value by 1/2, I'm going to multiply each y value by 2. So the clear ones are, for example, at 90, when sine of 90 is 1, 2 sine of 90 is going to be a value of 2. 0 is going to stay where it is. 180 is going to stay where it is. 270 is going to come all the way down to negative 1, and 360 is going to stay where it is. So what do I end up getting? I get this sine function which has been pulled up and pulled down. It looks something like that. Because we're doing it over the interval of negative 360 to 360, I'm going to just copy this guy and bring him over here. And here you can see that the base sine function, y equals sine of x, has been kind of like pulled up by a factor of 2. Everything is being stretched vertically by a factor of 2. Here 2, and here as well. So on the one hand, we get the compression with the green line, and on the other hand, with the red line, we get this vertical stretch. The last one is a -1. In other words, it's not doing anything to sine other than making it negative. So what does that look like? Well, let me do this in blue. So here we go. So I'm going to have f of x equals -1 sine x. And you're taking every sine of x value and multiplying it by -1. So for example, over here at 90, sine of 90 is 1. If I negate that, it'll be -1, which is down here. Use larger dots. Sine of 180 is just going to be in the middle. Sine of 270, well, that's going to bring us back up to 1. I'm going to have to move this out of the way. Sine of 270, that'll bring us up to 1. 360 will be at 0. 0 will be at 0. So what does this look like? I'm going to come down, shoot up, and come down again. Let me try that again. Down, shoot up, and come down. Because we're going over -360 to 360, I'm going to just copy that and move it into place. And there you have negative sine of x, which is essentially the original one. Let me just go over the original sine curve for you. I'll do that in black. Here's the original one. Okay. Nice and undulating throughout. And then when we reflect it in the blue line, it's the same thing, but literally upside down, or reflected in the x-axis. You get that really cool pattern going on. Of course, you can extend these in both directions. You can go, more positive if you like, this way. You can go more negative this way. Ideally, they go on forever, but we're just going to look at this one interval. And really, at the end of the day, one cycle is all you need, because the rest are just cookie cutter types of that one.